In the investigation that we just completed, we learned that a special relationship must exist among the lengths of the segments of a triangle in order for them to form a triangle. We discovered what must be true about the three lengths, and we're now going to state that as a theorem. So the Triangle Inequality theorem says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if we look at our triangle here on the right, the three relationships we'd be talking about would be, all right, if we say the length of PQ plus the length of QR, that would have to be greater than the length PR. And if we then said the length PQ plus PR, that sum would have to be greater than the length of QR. And then finally, PR plus QR would have to be greater than the length of PQ. Now, when we're looking at three different side lengths, it's not going to be necessary for us to write three different inequalities. We only need to show that one of the three triangle inequalities is true. That is, if we use the correct inequalities. The three inequalities we want to use is we want to look at the two shortest lengths and make sure that the sum of the two shortest lengths is greater than the longest length. All right, let's look at some examples to see if we can use this theorem correctly. So in example 1, we're given the lengths 8 feet, 15 feet, and 17 feet. Again, I want to choose the two shortest lengths, so that would be 8 and 15. So if I do the sum of 8 plus 15, that is greater than 17, because it's 23. So my conclusion would be that yes, we could form a triangle with those three lengths. If we look at example 2, we have the lengths 6 meters, 14 meters, and 8 meters. In this case, if I do 6 plus 8, that's actually equal to 14, so that is not greater than 14, and I just put a greater sign with a slash through it. So my conclusion there would be no, we cannot form a triangle with those lengths. And my explanation is just that inequality with the slash through the greater than sign. And then finally, in example 3, again, we want to look at the two shortest lengths, so that would be 2 centimeters and 8 centimeters. When we add 2 plus 8, that's just equal to 10. So again, that length is not, or that sum is not greater than 11. So our conclusion here would be no, we cannot form a triangle with those lengths. The other thing we can do with our triangle inequality theorem is we can determine the range of possible lengths for a third side when we're given two sides of the triangle. So in other words, what would the length of the third side have to be in order for us to form a triangle? So looking at this example here, if the measures of two sides of a triangle are 3 feet and 7 feet, what is the range of possible values for the third side? So when we talk about a range of possible values, a range implies an upper boundary and a lower boundary in most cases. And so that's what we're looking for. We're looking for a range of numbers. So I've broken down the steps that we can go through in order to figure out that range of numbers. So first of all, it says draw a diagram and let X represent the length of the third side. Now I have no idea what this triangle actually looks like. But again, I can just make a sketch. So I've got 3 feet on one side, 7 feet, and then we're trying to find the length of, or the range of values for that third side. So we are going to use our triangle inequality theorem, and we're going to set up the three inequalities. So the sum of 3 plus 7 would have to be greater than x, and 3 plus x would have to be greater than 7, and then x plus 7 would have to be greater than 3. So now what we have to do is we need to go through and solve the three inequalities in order to find the range of values. So our first one, 3 plus 7, so we have 10 is greater than x. So that means that x has to be less than 10. If we look at our second inequality, to solve that, we're going to subtract 3 from both sides. So x is greater than 4. Okay, so x must be greater than 4 in order for us to form the triangle. And finally, the last one, when we subtract 7 from both sides, we get the inequality x is greater than negative 4. Okay. This inequality can automatically be eliminated because we can't be talking, remember x represents a length, and we cannot be talking about a negative length. So if we look at what remains, we have x is less than 10 and x is greater than 4. That gives us our range of values. So when we write our range of values, we want to write them as a compound inequality. Now again, this is from Algebra 1, and when you write a compound inequality, you write it in this form. The lower boundary is less than x, which is less than the upper boundary. Another way we say that is that x is between 4 and 10. So writing our inequality here, our range of values, 4 is our lower boundary. So 4 is less than x, which is less than 10, 10 being the upper boundary. You know, if you wanted to check yourself here, pick some values that are, first of all, between 4 and 10 and plug them in, but also pick a value like 3. If we put 3 in for x, well, 3 plus 3 is only 6, so that would be less than that third side, so it wouldn't work. Or if we picked a value greater than 10, say we picked 11, if we put 11 as x, well, if we did 3 plus 7, that would be 10, which would be less than 11. So obviously our range of values for this triangle must be, for the third side, must be greater than 4, but less than 10. In the next video, we're going to take a look at a couple of other examples for finding the range of possible values for the third side in a triangle.